Start with the name of Allah, who is the most gracious and most merciful. Today, my topic name is types of probability, and my name is Zishan Ali Jagrani, roll number 2K18, base 2K18, and subject statistics and Anand probability improver. These are the contents, inshallah, we will discuss here in this video. Introduction, concepts of various terms, approaches are types of probability, theorems of probability, this discussion of problems, and conclude and a reference. Introduction. Probability theory is a very fascinating subject which can be studied at various mathematical levels. Probability is the foundation of statistical theory and application. Several mathematicians like Pascal, James Bero- Bernoulli, and De Moivre Bayes applied the theory of the permutations and the combinations of inequality. 45. Or calculate the probability today. The probability theory has become one of the fundamental technique the development of statistics. The term probability in statistic refers to the chances of convenience and event among the large number of possibilities. Terminologies. Random experiment. Experiment or a trial is repeated under the same condition if any number of times and it is possible to count the total number of outcomes is called a random experiment. Sample space. The set of all possible outcome and a random experiment is known as sample space and denoted by its set as. This is similar to universal set and set theory. The outcome of the random experiment are called sample points or outcomes. Event. An event is an outcome of a trial meeting a specified set of conditions. Under other words, event is a subset of sample space S. Events are usually denoted by capital letters. They are different types of events. Null or impossible event is an event which contains no outcome. Elementary Number second, elementary event is an event which contains only one outcome. Number third, composite event is a event which contains the two or more outcomes. Number four, sure or certain event is an event which contains all the outcomes of sample space. Exhaustive events. The total number of all possible elementary outcomes in a random experiment is known as exhaustive events. In other words, a set is said to be exhaustive when no other possibility exists. Favorable events. The elementary outcomes which can entail or favor the happening of an event is known as favorable events. For example, the outcomes which help in the occurrence of that event, mutually exclusive events. Events are said to be mutually exclusive if the occurrence of an event totally prevents the occurrence of all other events in a trial. In other words, two events A and B cannot occur simultaneously. Equally likely or equiprobable events. Outcomes are said to be equally likely if there's no reason to expect one outcome to occur in a preference to another. For example, among all the exhaustive outcomes, each of them has equal chance of occurrence. Complementary events. If let E denote occurrence, let E denote let E denote occurrence of event. The complementary E denotes the non-occurrence of event E. Complement of E is denoted by both letter E. Independent events, the two or more events are said to be independent in a series of trials if the outcome of one event does not affect the outcome of the other event or vice versa. In a, In other words, several events are said to be dependent if the occurrence of an event is affected by the occurrence of any number of remaining events in a series of trials. Measurement of probability. There are three approaches to construct a measure probability occurrence of an event. They are number one classical approach, number two Fourier approach, and number three is a axiomatic approach. Classical or mathematical approach. In this approach, we assume that the experiment or the trial results in any one of the many possible outcomes, each outcome being equiprobable or equally likely. Definition: if a trial results in exhaustive, mutually exclusive, equally likely, and independent outcomes, and uh, if the aim of one of the favorable for the happening of the event E, then the probability of P of occurrence of the result E is given by number of outcomes favorable to event divided by exhaustive number of outcomes, or we can show by the symbols like m divided by n. Empirical or stat- statistical type approach. The approach is also called a frequency approach to probability. Here, the probability is obtained by actually performing the experiment large number of times. As the number of trials increase, we get more accurate result. Definition: consider a random experiment which is repeated by large number of times under essentially homogeneous and identical conditions. If denotes the number of trials, and m denotes the number of times in the event A is occurred. Then the probability of event A is the limiting value of the relative frequency, like m divided by n. Axiomatic approach. The approach was proposed by Russian mathematician A. Kolmogorov in 1933. Axioms are statements which are reasonably true and are accepted as such without seeking any proof. Definition: let S be the sample space associated with a random experiment. Let A and B be an event S. Then P uh, uh, inverted comma taken into a comma brackets is the probability of occurrence of A if the following examined are satisfied, like P taken into a bracket is greater than 0 where A is an even. P taken into S is equal to 1. Number third, the P taken into bracket AUP of is equal to P taken to A plus P taken to B when even A and B are mutually exclusive. The types of probability. Theoretical probability. Theoretical reasons, we assume that all n possible outcomes of a particular experiment are equally likely, and we assign a probability to each possible outcome. Example: the theoretical probability of rolling a 3 on a regular 6-side die is 1 upon 6. Number two, relative frequency interpretation of a probability. We conduct an experiment many times, then say the probability event A is equal to how many times A occurs divided by how many trials. Relative frequency is based on observation or actual measurement. Example: a die is rolled 100 times, the number 3 rolled is 12 times, the relative frequency of rolling is 3. Rolling 3 is 12 divided by 100. Same formula is given. Number third, the personal or subjective probability. These are the values between the 0, 1, 0 and 100 percentage assigned by individuals based on how likely they think events are to occur. Example: the probability of my being asked on a table this weekend is 10%. Probability rules with examples. Number one, probability of an event is between 0 and 1. Probability of 1 is equivalent to the 100% certainty. Probabilities can be expressed at fractions. Like O is PR taken to A is 1. Number 2, the sum of the probabilities of possible outcomes is 1 for 100 percentage. A, B, C are the only possible outcomes. Then PRA plus PRB and PRC is equal to the 1. Example, a bag contains 5 red marbles, 3 blue marbles and 2 green marbles. The summation of these will be P red plus P blue and PR green is equal to 1. And 5 divided by 10 plus 3 divided by 10 plus 2 divided by 10 is equal to the 1. All the values will be equal to 1. The sum of the probability, number third, the sum of the probabilities of an event occurring and a outcoming is a 1. PR not A is equal to 1, or PR not A is equal to 1 minus PRA. These are the different ways. Example, a bag contains 5 red marbles, 3 blue marbles and 2 green marbles. P red plus P not red is equal to 1. Like ratio given by 3 is divided by 10 plus P not red is equal to 1. PR not rate is equal to the 7 by 10. Number four, if two events A and B are independent, this means that the occurrence A has no impact on whether B occurs and vice versa. Then the probability of A and B occurring is the product of their individual probabilities, like PRA and B is equal to PRA dot PRB. Example: a rolled or die and a lip on a coin, like P8 and a roll 3 is equal to PRH and PR3. 1 by 2 is enter. 1 by 6 uh, is equal to 1 by 12. Number 5. That if two events A and B are mutually exclusive, meaning A cannot occur at the same time as B occurs, then the probability of either A and or B occurrence and so some are of the individual probabilities PRA or PRB is equal to PRA plus PRB. Example, a bag contains the 5 red marbles, 3 marbles, 3 blue marbles and 2 green marbles. The, the PR red or green is equal to PR red plus PR pigment 5 upon 10 plus 2 upon 10 minus 7 upon 10. Number 8, number 6. If the events A and B are mutually exclusive, meaning it is possible that A and B occur at the same time, then the probability of either A or B occurring in the sum of their individual probabilities minus the probability of both A and B occurring. Like if given is a PRA or B is equal to PRA plus PRB minus PRA and PRB. Example, there are the 20 people in the room. If 20 girls, 5 with the blonde and a blonde and a blonde hair and a 7 with the brown hair, and the boys 4 with the blonde hair and 4 with the brown hair. There are a total of the 9 bonds and 11 with the brown hair. The one person from the group is uh, chosen randomly. The period of the blood like is equal to PR girl and PR blood blend minus PR girl and blend, like 12 divided by 20 plus 9 divided by 20 minus 5 divided by 20 is equal to 16 divided by 20. Number 7. The probability of at least occur event occurring outcome of multiple events is equal to 1 minus the probability of none of the events occurring. The PRA at least is 1 is equal to 1 PR none minus PR none. Example, a roll are coined 4 times. That is probability of getting at least one head on this four rows. Like PR at least one oish minus 4 is equal to 1 minus PR noish is equal to 1 or minus PRTTT is equal to 1. And number 8, if event B is a subset of event A, then the probability of a P is less than or equal to the probability of A. Like given PRB is PRA. Example, that there are the 20 people in the room, the 12 with the 12 girls, 5 with the blonde and 7 with the brown hair, and the boys are 4 with the blonde hair and 4 with the brown hair. A PR girl with brown hair is a PR girl, like given is 7 by divided by 20 is less than the 12 divided by 20. Thank you so much.